Well, welcome, ladies and gentlemen. Our next session, how to run a top 10 website publicly and transparently. Kunal is going to be our presenter, and we've got to make sure we stay on target for time frame because after this is keynote in here. So, take it away.
Thank you. My name's Kunal, or user LegoKTM, and today we're going to talk about Wikipedia, if you couldn't guess what the top 10 website was. I hope all of you know what Wikipedia is. It's a free encyclopedia. The main goal of this talk is to discuss transparency, and so each slide has a QR code where you can find the resources that are on that slide. If there's a dashboard, a graph, or a chart, or something like that. I'm not sure you'll be able to scan them here, but at the end there's a very big QR code with links with the slides. So Wikipedia is an encyclopedia, you know, the things that they used to like print on dead trees. And it's primarily edited by volunteers, and it's available under a free Creative Commons license. You can take the content and reuse it and remix it as long as you attribute it that it came from Wikipedia. And the goal of Wikipedia is really to compile the sum of all human knowledge. And that's a pretty daunting task, you know. On the left, that's a picture of what is the remains of the Library of Alexandria, which at one point was, you know, like the biggest collection of human knowledge. And it's a pretty daunting task, but a lot of people are working hard and are up to it. And as a side effect, you know, we really make the internet not suck, in my opinion. But just to give us, you know, to give an idea of the scale of the problem is that estimates by looking at topic areas suggest that we're about 5% done with collecting, you know, all of human knowledge. And I think that, you know, whenever I go on Wikipedia, no matter what I look up, I'll find something. And yet to think that we're only 5% there really, you know, gives an estimate of the magnitude of the tasks that's in front of us. So first I want to talk about how Wikipedia operates, you know, just building the encyclopedia, and we'll get to the technical part afterwards. And transparency is really a core principle of Wikipedia itself. So this is the article for Webb's first deep field as it looked about a week ago. It looks actually much better now. And it was the first image taken by the James Webb Space Telescope. And you can read the article. It's a nice article, explains a picture of the background. But you can also, in the top right, there's a little tab that says View History. And if you click on the tab, it'll show you the history of the page. And this is, again, the history from a week ago. But then you can go through and look at each individual revision of why people made the change. And then you can actually look at a diff of the changes themselves. And so this diff is someone just adhering to the manual of style and changing the numeral 6 to be spelled out SIX. And that's all great, but it doesn't really explain like how things happen or why things happen. And so there's another tab that says Talk. And that's really where all the discussions happen on Wikipedia. And each page has an associated talk page that you'll find some of these discussions on. And people will ask different questions. They'll discuss the validity of different sources. They'll see if something is phrased properly or could be phrased better, or, you know, whether something is unclear or jargony or could be better. And this is really, you know, the heart of the collaborative spirit of Wikipedia is that if you're not sure of something, instead of making the edit, you can just discuss it with other people. And really, the technical infrastructure works the same way. We adhere to these same principles of collaboration, transparency, and openness. So just at a glance, Wikipedia is the 7th most visited website, and I got that stat from Wikipedia, so I don't know if it's true. It's maintained by a collaboration of volunteers and staff members, and all of the source code is available under free licenses. The majority of it is under the GPL copyleft license. And like I said, it's developed in a collaborative manner that you can observe and what I'll kind of walk through today. But first, a quick segue. Naming things is a hard computer science problem, and Wikipedians kind of suck at this. So, the globe logo is Wikipedia, the encyclopedia, what you're really familiar with. In the middle is Wikimedia. You know, the Wikimedia movement is a social movement designed to, you know, spread free knowledge, but it's also the name of the nonprofit organization that maintains, you know, trademarks, legal status, and runs the servers. That's the Wikimedia Foundation, or WMF. And just as an analogy, Wikimedia is to Mozilla as Wikipedia is to Firefox. So that's kind of the relationship. And then if you flip MediaWiki around, or if you flip Wikimedia around, you'll get MediaWiki, which someone thought was a brilliant idea of how to name the wiki software that powers Wikipedia and hundreds of other wikis around the internet. I may use them interchangeably. This is kind of what it is, but hopefully it'll make sense. So a brief technical history of where Wikipedia came from, and that's what the Wikipedia homepage looked like roughly in November, December 2001. So there was a .com company called Bomis, and one of their side projects was Nupedia, which was a public encyclopedia, but everything had to be reviewed before it could be published, and it was very slow. And so they decided, why don't we create this project called Wikipedia, where anyone can edit, and eventually, once the articles are good enough quality, we'll move them over to Nupedia. And about a few months into the project, Wikipedia had hundreds, if not 1,000 articles, and Nupedia had 60 or 70. It was very clear which project won. And at this time, the servers were in San Diego, California, and they were owned by this for-profit company called Bomis, but volunteers got access. And within a few years, Bomis realized, the leaders of Bomis, including Jimmy Wales, realized how important Wikipedia was, not just as a commercial thing, but also as just a resource for public good. And they split it off into the Wikimedia Foundation as a nonprofit that would be, that would safeguard the legacy of it going forwards. And then in 2004, the servers would move to Tampa, Florida, and that was primarily because the co-founder of Wikipedia, Jimmy Wales, lived there, and he was the one who, installed the first Tampa servers. Coincidentally, this was also the time that the first off-site backup of Wikipedia was taken because they were afraid of hurricanes. And it is kind of wild to think today that no one bothered to take a backup of Wikipedia for 3 years, knowing how important it is today, that we were one failed hard drive away from not having Wikipedia or having to start all over. Today, the story is very different. There are 6 different data centers around the globe that serve Wikipedia to users. There are 2 core data centers in Virginia and in Texas that run the MediaWiki software and serve the Wiki platform. And then there are 4 caching point of presence data centers that are in San Francisco, the Netherlands, Singapore, and the new one just opened up in France earlier this year and is starting to serve traffic. And this is an overview of the technical architecture of how your web request flows, starting coming in from the caching layer to the application servers, and then how it hits the storage layer. I'm not going to explain this. I'm mainly showing this for 2 purposes. One, to give you an idea of the complexity of the technical stack. You can see that there's a lot of different components. There's a lot of different caching layers and ways that data moves through the flow. And also the second thing is to show you that this diagram is publicly available on the internet. You can read it, you can look at it. It gets updated every few years or so as technology changes. And if you go to our technical wiki, which I'll link later, you can just type in any of these different components, whether it's the back-end cache or whether it's, how we use, things like McRouter and Envoy. And you can just type them into the wiki and you will find all of our technical documentation on how we use it, what we use it for, where it's deployed, where you can find the configuration. All of that is publicly available. So these are, the main technical points you get in that I'll go over today. So the first is where we host our code, which is on this code review system called Gerrit, and is also mirrored to GitHub just for convenience and to make it easier for people to find. We publish our metrics and statistics at grafana.wikimedia.org. Our bugs are tracked in a system called Fabricator, and you can see the URL. And then our documentation is kind of spread out. We have 2 different wikis, wikitech.wikimedia.org, which is mainly focused on the Wikimedia-specific documentation of how we deploy things, and MediaWiki.org, which is really about the MediaWiki software, which can be used by anyone, but is also has stuff that's applicable to how Wikipedia uses MediaWiki. And doc.wikimedia.org is another place for documentation, and that's mostly auto-generated documentation from code. So in the last 90 days, we saw around 13,000 patches submitted, and from over 350 different authors, some of whom are staff and some of whom are volunteers. All patches to the MediaWiki code base have to be approved by someone with we call them +2 rights, and basically you vote +2 on the change, and then the change will get merged if it passes CI. And code gets deployed once a week. We create a branch, and then that branch is progressively rolled out from the smaller wikis to the biggest ones, including the English Wikipedia. And we call that the deployment train. And all the servers are maintained using a system called Puppet, and that code is deployed immediately. And I'll talk about Puppet a little bit later. So, who is submitting MediaWiki patches? And remember how I said earlier it's a collaboration between staff and volunteers, and aside from the fact that a dude named Sam is incredibly awesome, it's actually a pretty clear breakdown of, about half the patches, half of the people on the list are staff and half of them are volunteers. And when I looked at the actual breakdown of everyone, it was around 53% of patches are submitted by staff and the rest come from volunteers. So it actually is a pretty close equilibrium between staff and volunteers. And then on the flip side, who's approving these patches? And it's actually pretty similar that in the top 6 people, half are staff and half are volunteers. And this is once a patch is merged, it'll automatically get deployed. And so, volunteers actually do have significant power in getting, patches from, reviewing them and getting them deployed into production. So Puppet is, it's a way to declaratively state what should be installed or running on a server. It's similar to Ansible and other tools in that category. It basically is root. Puppet runs as root, so it's limited to our site reliability engineers and a few volunteers who also have root. And the Puppet code is public. You can find the Git repository, but all the passwords and secret keys are in a private repository that only exists in the production servers. And other people who don't have access to servers can actually test their Puppet patches in virtual machines. If you've never seen Puppet code before, this is kind of what it looks like. It's this mishmash of a Ruby syntax with this custom Puppet syntax, but and this is how we deploy MediaWiki web servers. But like I mentioned, the really cool thing is that anyone can grab our Puppet code and test it in a virtual machine. So we have another team called Cloud Services that provides computing resources, which is an OpenStack deployment for volunteers and staff. And you can take the same Puppet code that is running in production, and you can just spin up a VM, apply the Puppet role, and you can be running roughly as close as you can the same exact code that's running in production on your VM. The only difference is you don't have any private user data, so we can give out access to this VM that is running, again, nearly identical code to anyone. And this means that it's really easy for volunteers to test their code, have a simulated working environment using the same system that is running in production. And it really makes it a lot more accessible to contribute. And so then one of the key features is that we have this beta cluster, which is a replica of some of the production wikis that we have, and it's just running the latest version of MediaWiki as it's been merged into master to catch different integration issues. And again, we can give out access to this beta cluster where people can test their MediaWiki code or debug problems in MediaWiki code we can give it out access much more liberally than we do on production servers, just because there's really no private user data here. And in a similar vein, we have database replicas, and so everything is stored most of the database stuff is stored in MariaDB, and so we have redacted replicas of these databases are available to cloud service VMs, and if you want to do stuff locally, you can set up an SSH tunnel. And so basically, we have all these rules that strip out all of the private data out of, or null the fields or zero them, and then return the rows that are public. And so then, now what's the next step after that? We have a web tool that allows you to just run SQL queries straight from the web. It's like PHPMyAdmin, but actually secure. And one of the really cool things is that once like a technical user who understands SQL like writes a query, we see non-technical users, or I don't even consider them non-technical, but like traditionally non-technical users, will just start learning SQL via copy, paste, and modify. They'll start tweaking the queries. They'll, like just first it'll be strings that are really easy to modify. Then they'll start adding new conditions or copying and pasting from other queries, combining them together. And it's really powerful, and it's really cool to see that, like just because we made this resource available, people who are, would consider themselves traditionally non-technical users or don't have a computer science or programming background, are actually writing SQL queries to get data based on, like the maintenance tasks that they want to do on wikis. So shifting gears, like I said earlier, we publish most of our statistics and metrics, and so this is this is how many requests per second we're getting globally, and so as the 7th most visited website, that amounts to at peak around 130,000 requests per second, and the shape of the graph is actually people being awake and going to sleep. That's how our traffic patterns are determined. And these are just some more statistics. We have the total request volume, how many errors we were serving, and you can see that in the error chart, clearly we were having some problems at the beginning of it before they all like zeroed out. And another metric we measure is successful wiki edits. Like if everyone stops editing, that means there's a problem on the wikis. And you can like get this breakdown for the health of like individual servers. So this is MW1312, which is a MediaWiki app server living in the Virginia cluster. And you can see like the CPU, the memory usage, networking. If you like scroll down farther, you can see like temperature, load averages. You can like break this down for, and every server and virtual machine that we run in our production cluster is on this page. And you can look at the database layer. This is an aggregated shot of all of the database rows that are being written and read to every single one of our database clusters. And you can also look at it at the data center level. Like this is our Singapore data center, and you can see that like Asia is clearly waking up and starting to access more data on Wikipedia, so that way the networking charts are like going up. And you can look at like how many servers there are in our data center. All of this information is publicly accessible, and anyone can just start browsing through it and learning things. And so, like on Wikipedia, we have talk pages. A lot of most of the communication around this development happens in public as well. So we have a traditional mailing list called WikiTech-L. Then we have the like Fabricator and Garrett comments, and then we have a whole host of IRC channels on the Libera chat network. And the biggest channels of these are bridged to Matrix to provide a little more nicer user interface for people who are not used to IRC. So now I kind of like want to walk through an example of how transparency was key in solving an outage. And so this happened towards the end of 2021. And users can upload files to Wikipedia, and we have a max file size of 4 gigabytes. But like I mentioned earlier, we have 2 core data centers. And so when you upload a file, in the back end, it's actually being copied over to both data centers. So you have one upload, and it ends up in a system called Swift, which is like the OpenStack version of S3. And so your file is uploaded very quickly to the local data center. And then it also has to take the extra cost of going from one data center to the other, so the speed of light from Virginia to Texas. And so what we found was that for whatever reason, files were going to the other data center very slowly. And it was about 2 megabytes per second, and we have a 300-second timeout, which basically gives you a 600 megabyte file. And people are uploading files up to 4 gigabytes in size, and so this is a real problem for any large file upload. And this coincided with the upgrade of our servers from Debian Stretch to Debian Buster. So something in that large upgrade caused these file uploads to slow down. And we didn't really have a good clue of what it could be. And so as like I was the lead person investigating this, and so my first step was basically to like try and reconstruct, like can I minimize the code? Can I just use plain a curl command and send the code off? Can I get the upload to finish in time, or will it be really slow? And then also, can I just write like now using like a very minimized PHP reproduction of like stripping the code out of the two main classes that are responsible for handling file uploads? Can I like minimize it down to just like the very basics, so that still reproduce the issues, so we can like run it under strace and a few other things. And what I found was that when I ran it with the command line curl, it finished instantly, but when I ran it with the PHP code, it was still slow, which is great. Now I have like two different things that we can compare. And so in the Phabricator ticket, I pasted like everything that I was doing, all the commands I was running and all of the output that I got. And I have a little more debugging, like, okay, if I like switch to using, instead of using curl in PHP, if I use stream wrappers, then it still works, but stream wrappers have a much smaller max file size. And I noted that like we had, as part of the upgrade from Stretch to Buster, we had upgraded libcurl, from 7.52 to 7.64. So there were going to be changes, and maybe it was one of those changes. And my like final strace showed that it was like calling fread a lot, and I thought that was suspicious. And then I went to sleep, and my colleagues took over. And they said that, okay, my hypothesis is correct, but it's not like the fread syscalls that are causing it. It's the fact that we're making 820 round trips between the data centers because we're making really small chunks. And the round trips will add up a lot just because we're in a different data center, and that's what was causing it to take so long. And they did some more like statistical analysis in Wireshark that showed like this is clearly the problem. We're sending too many round trips and it's going too slowly. And then a volunteer who was following the ticket, and this volunteer has no server access, no access to private data, and probably doesn't have a full understanding of like the technical architecture. But they were reading the ticket, they were following along, and all of us who had been commenting so far had been doing so in like a very verbose way, where everything we were doing was written out. And the volunteer says, but the command line curl output is using HTTP1, and the libcurl output from PHP is using HTTP2. Can we, either force one of them to use HTTP2 or force HTTP1? And that was actually the issue, was the fact that the use of HTTP2 was causing it to do way more round trips than necessary. And as soon as we forced it to use HTTP1, as the volunteer noticed was wrong, that immediately fixed the issue. The uploads finished incredibly quickly. And at that point, it was, okay, just write a patch to force it to use HTTP1, and we're set. And then the volunteer in a later comment actually found, like in the libcurl changelog, where it says, okay, we're going to default to HTTP2 now if the method is not explicitly specified in the changelog period from Stretch to Buster. And so that like totally validated our theory. And at the same time, this came from a volunteer. And in the end, it was the verbosely pasting publicly is what allowed this volunteer to come up and solve the issue. And it's likely that, the staff SREs, we would have figured out the real cause eventually, but I think it would have taken more time, a few days at least. And we have like a full incident report that you can read, and that incident report also links to a really good Cloudflare blog post that explains why in certain conditions HTTP2 is actually slower than HTTP1. So if you're interested in the technical reasoning behind it, I would recommend reading that. So jumping over to IRC, we have a ton of IRC channels. This is the list of technical IRC channels that go from M to T, because that's how much I could fit into this screenshot. There's a lot more, and you can like peruse the list of IRC channels. You can join them. Nearly all of them are publicly open, and a lot of them are actually publicly logged, so you can actually go back and read old conversations. These are the main three channels that, if you're interested. There's the operations channel, which is the main coordination channel where deployments happen, where incident discussion happens. There's the SRE channel, which is the discussion amongst SREs. And there's the tech channel, which is for like end user support and help, and people will often just ask questions and just have general, like anything that fits under technical discussion is like totally on topic there. And we also have a private security channel for dealing with DDoS attacks and active security issues. And that is used pretty sparingly just because everyone in that channel also recognizes that using that channel is excluding a significant amount of volunteers and even staff members who are not in that channel, and that's why discussing things publicly is preferred. So this is from Thursday, and this is just a snippet of an IRC log from the operations channel. And this is Tavi, a volunteer, pinging to the people who are responsible for the deployment, asking if the deployment can be rolled back because it's broken, coincidentally again, uploads. Can you imagine going on an IRC channel and pinging someone from Amazon, Google, or Facebook saying, hey, your deployment is broken, can you please roll back? Like, this level of like access is really like you don't have that anywhere else. And within like 3 or 4 minutes, Gina says, okay, I'll roll back, and then the deployment tool says, yes, it's Gina has rolled back the wikis to a previous version, and the deployment tool uses this thing called like an exclamation mark log, which means that all of the entries end up in what we call the server admin log. And this is a log for like any action that happens on a server that isn't going to be reflected anywhere else, like like when you like merge a patch, it's logged in Git, right? But for a lot of options, like if you're rebooting a server or if you're adjusting some configuration in a database like etcd, then those things, or depooling a server, like those things are not reflected anywhere else except on the server in your like bash history. And so the server admin log like collects all of that. And all of our deployment tools will automatically send logs to the server admin log, and you just type in exclamation mark log in IRC, and it'll go to a wiki page. It'll go to Mastodon, and it'll go to Twitter. And on the right, I have the Twitter search for the word "oops" in the server admin log, and the other fun one to search is WTF, and you can see what people were frustrated with like 5 or 6 years ago. And the Twitter and Mastodon integration is kind of new, but the wiki archives go back to June 2004, which is, you can see what Wikimedia sysadmins have been doing all the way starting in June 2004 up until like literally right now. There's, just pages of archives, and you can search through them, you can read through them, you can see like people like reverting stuff, dealing with outages, not knowing what they're doing, or you can just like see like general maintenance, like pooling and depooling servers. So there's a lot of like valuable history there. The other thing that's really cool on IRC and the operations channel is most of our alerts and monitoring will show up there. And so we use a combination of Isinga and Alert Manager to do notifications. And this is when there was like a blip in networking. And so Isinga thought a bunch of hosts were down just because it couldn't reach them. And the 2 lines that I bolded have the word like hash page in them. And that's special because it means that SREs were paged for that. So you can see that SREs have already been paged, and you don't need to like try and ping someone independently that all of these alerts have gone off. And both of those are database servers. That's why they triggered pages. But and then at the very bottom, you can see Reuven going, uh-oh, like because he's been paged, and within a minute he's on IRC being like, why are all these servers disappearing? So far, everything I've talked about has been public, right? There's like a lot of information that's public that's on, on the wikis and in Phabricator that you can, and IRC that you can all access. But there is some private information that we do have. Overall, Wikipedia has like very little private information compared to most websites. We don't collect your address, we don't collect your credit card information, we don't, collect your phone number, and even registering with your email is optional. Literally, the only private thing we have is your password and possibly your email address if you chose to give it. So there's very little private information. But still, volunteers need to sign an NDA to get access to like debug logs, web request logs. We have slow SQL queries that can be used as DOS vectors or security tickets. And so the NDA process, you can like read, the NDA is not even secret. You can read the terms on the wiki itself. And the bar for like signing an NDA has been lowered over time. Previously, you needed like C-level sign-off on everything to like give a volunteer access, and now any Wikimedia Foundation employee can vouch for you, and then the legal department will like prepare the NDA and get it signed. And when I checked earlier this week, there were exactly 100 users in our like NDA LDAP group, which it controls it. And so there's like a decent amount of, and all those people are like volunteers. None of them are foundation staff, which has a separate group. So that really shows like the like scope of people of even for like this like private information, we've been able to expand the access for it. And server access, not like the little kitten has gotten, but real, SSH access. Again, volunteers need to sign an NDA and go through a form of deployment training. And this access is controlled by the release engineering team, which is the one that coordinates and manages most of the deployments. There are about 7 volunteers with MediaWiki deployment access. They can deploy patches, they can deploy security patches, they can inspect the state of code, they can do interactive debugging. There are only 2 volunteers with root. One of them is me. And me and the other person who's a volunteer with root, we were both former staff. And in the past, there used to be volunteers with root, which I think was a really good like equalizing principle and good governance, that it's a mix of volunteers and staff who are making these like root level decisions. But over the years, the SRE team has grown more professionalized, and it's expanded a lot, that it's really hard for volunteers to justify root access, because anytime you need something with root access, it's not like, oh, I'm blocked on it, because you just ping someone and someone on the SRE team will be awake and be able to help you. I would like to see that change. I think it's important that there are volunteers with root access, but it's kind of a practical problem right now. All of what I have talked about so far about like transparency and access, I think it's important not to understate how hard this can be to keep this culture up. It is a constant fight to keep things transparent. A lot of the systems that we have are designed to be open by default. Like Gerrit is public, Phabricator is mostly public, all of our statistics are public, our IRC channels are public. So as long as you like use those venues, your things will be public by default. But regardless of this, people still like trend towards closed platforms. Like people want to use Slack instead of IRC. People want to use Google Docs instead of Wikipages. And it can be difficult to like constantly be the source of friction, being like, hey, I know you shared a Google Doc with me. Can you actually like just post it on the wiki and I'll give you my feedback there? Or when someone pings you on like the internal like Wikimedia Foundation Slack, like actually this is a discussion we should be having in public, so that way volunteers can participate. Can we move it to IRC? And it's difficult, especially when like you're being pinged and the answer is just like yes, like are you really going to force the person to like context shift just to give them that answer? And then there's some things that have to be private, like legal advice. Lawyers can only give legal advice to like the company, and so the only people who can actually read their like detailed advice are foundation staff, and then the foundation staff have to like summarize it to the volunteers and be like, this is what the lawyers said, and I'm sorry I can't explain it to you, but this is what we have to do because the lawyers said so. And that can be frustrating, especially if you disagree with the lawyers. And then I think that people can really be intimidated by having to do everything publicly. Wikimedia also has like a very strong component of value of privacy, and we're asking everyone to do everything in public. And these things are archived. Once they're public on the internet, they're archived forever, and we keep our own records forever. And the idea that any mistake or silly comment or bad joke, especially if it has aged poorly over time, is going to be public and archived forever. Do you really want that? And I was in an interview for my new job, and the person interviewing me pulled up a random wiki page that like I had worked on, like a technical proposal, and being like, all of these users didn't like your proposal. What do you have to say about that? And I was like oh my goodness, yeah, they did say that, they didn't like my proposal, but I discussed it, and like the idea is that like any future employer or interviewer can just pull up what you've been working on and read all of your comments is I think it's kind of intimidating. I think the one thing that works in our favor is that we're very happy for people to be publicly anonymous, and even like there are people with merge rights to MediaWiki who we don't actually know their real name or their real life identity. It's just that they've done good work, they've become trusted in the community, and so we've given them the rights. To sign the NDA, you do have to use your legal name, but there's no, the legal name can just be restricted to the lawyers, and it can be kept private. So the fact that we allow people to contribute anonymously does kind of mitigate that a bit. But I think it can turn people off and is something to keep in mind. So finally, what can you do? I think that this model for transparency is not something that is like uniquely special to Wikimedia, that only we can do it. I think that any other public interest website should try and do the same, and I think that even if you do it for your personal website, I think that's good for the internet. I think this level of transparency, helps make the internet not suck. And really, the thing is to start gradually. Don't try and make everything public at once. That can be very difficult and a real like culture clash. I find that documentation is the easiest place to start, and I will say that wikis are the best, of course. But even markdown files in a Git repository are decent as well. As long as it's there. And just start writing things down, even if it's just a list of like, these are the server components we use. We use Nginx, we use Python with like gunicorn, and it's managed by systemd units. And even if that's literally the list, it's a place to start. And it's much easier to iteratively add things than it is to start from scratch. And once you start building a community, other people will start documenting things for you. And I would also say that like it's okay to lose control. Like when it comes to our code, we're like very picky about like the syntax and the spacing and the formatting and how methods are named and how like all of that. And like you kind of have to like lose control with wikis. Like people will organize it the way they want, and as long as it's not like destructive, then accept it and just go with it. The important thing is that people are contributing, and eventually you'll move in the right direction, and you'll grow to like it. Then after, once you've started getting some documentation done, start publishing your server configuration. What does your Apache configuration look like? What does your Nginx configuration look like? What are the systemd units that you're using? I like analogizing this to like how people publish their dot files. Like people want to show off the cool tricks they have in their .zsh and their .bashrc, and there's like lists of like awesome dot files where you can see like a list of like other people who have really cool dot files and like how they've customized their bash prompt. Like people have like really cool tricks hidden in their server configuration. Like you should publish that too. There's a lot of like material that can be learned, or just that's interesting to look at. The catch is that you have to figure out how to separate your passwords and your private data from that. But really, that's a best practice you should be aiming for anyways, to separate private data from data that's not private. And then finally, track issues publicly. This can be difficult because oftentimes you don't want to like show that you have bugs, but this is also the best way to get people started, is to show that it's not perfect and that there's room for improvement. And even if you just literally like write like a line like this is buggy, and file that as the issue, that's fine as long as it's there. And you don't know that if there's a volunteer, or we've had cases where like the upstream author will like see the ticket in our repository and they'll be like, hey, I'm the upstream for this, can I help you solve what your problem is? And then even though you just had like one line, then you like are prompted to go into more detail about what the issue is. And having like an easy or good first task category is a good way for people to get started. And then just in general, just keep up the fight for transparency. Like be the little source of friction. Choose your battles of when you want to ask people to document something publicly, or when you want to have a conversation in public as well. And if you're interested in contributing to Wikipedia, we have a lot of work to do. Like I mentioned earlier, we're 5% there. Whether you want to edit the projects or whether you want to, contribute technically, there's a lot of work. The easiest way is to just lurk in our IRC and Matrix channels. Something might catch your attention. Someone might be asking a question about the thing you have like subject matter expertise in, or you might just find the conversations interesting. I have 2 QR codes on this slide. The first is the guide of how to become a MediaWiki hacker, which walks you through like setting up our Git setup, how to use like our Docker or VM-based MediaWiki setup. And the second is actually this brand new Wikimedia developer portal, which gives you a lot of links of different other projects that are not explicitly MediaWiki that still need contributions. We have like bot frameworks, we have like different developer tooling. There's a lot of stuff out there. And thank you. That's it. We have that's the QR code for the slides. That's different ways you can reach me if you have questions. And yeah, if people have questions. Yeah, I think there's a mic back there if you want to use it.
Thank you. This was really interesting. And I'm wondering, since it sounds like you're sort of the biggest website to scale doing so much in public, have you run into security issues by sort of having the biggest version of something so public, and how have you resolved that friction? Does the question make sense?
Yeah. Yes. There's like a lot of people who are like afraid to like publish version numbers or details about that. But I think the main thing is that you have to stay on top of security practices just in general. Like you have to be tracking, the upstream security issues. You have to be tracking, so we're all based on Debian. And in fact, one of the members of the Debian security team works for the Wikimedia Foundation. And so we're like always up to date on what the existing security issues are. And we actually take it a step farther, and I had this prepared. We like publish all of the version numbers. If you go to special version on any MediaWiki installation, you can see like what the MediaWiki version is, what the PHP version, what the database is, and all these different services, and you can see all the extensions installed, what their versions are, what the PHP libraries we use. In general, I think security through obscurity doesn't work. Like at best, all we get is all these like automated scanner reports from people looking for bug bounties saying like, oh, you're using an unsupported version of this, you have this bug, and then you're like, did you actually test the bug? It doesn't work because we're using a patched version of the software. So yeah, I like there are always times, like when that people do find security holes, and we just have to patch them. And we have practices for deploying security patches privately that then get responsibly disclosed to like other people using MediaWiki. But the answer is like you just have to stay on top of security whether you make it public or private.
Hi there. First of all, thanks. That was a great talk. One thing that I'm wondering about is, are there any sort of like statistics on volunteer burnout, if such a thing exists?
I don't have any statistics offhand, but I know it's a real thing. Volunteer burnout is real. I think that people, like oftentimes, so it works both ways. There are volunteers who are still involved who are like around in like 2005, 2006, and then there are also people who like will show up for like 1 year, provide these awesome contributions. Like you get them their like merge rights, and then they just disappear, and you never hear from them again, and have no way to contact them. It's a mix of both. I think the main thing is that we have to like strengthen and grow the community so that no one person feels overburdened, that they have too many maintenance responsibilities, and we can share the load. And if people need time off, we should give them time off rather than letting them go all the way up, burn out, and then we lose them forever.
Thanks.
Thank you for the talk. I have a few questions for you. You can pick your favorite amongst. One technical question. I'm curious if you could say something about your usage of OpenStack, how you use it, your experience, why you chose to use it. Second question, you said fighting for transparency, which I think is a commitment to transparency at the foundation of Wikipedia that is wonderful and awesome and so strong. In your own word, what would you say is that strength coming from? I could say it in my own word, but I'm really curious to see how you would articulate it.
Sorry, could you clarify the last part about transparency? What were you asking?
Where does that strength of commitment comes from? when the going got hard, right? You mentioned that it takes an effort to maintain that transparency. Where does that strength come from?
Yeah, so I'll answer this one first. You know, transparency is really about like making sure that in the future we have access to this information. You know, like if I discussed a technical problem in like PM with someone and lost the IRC logs, then like we have no way of knowing what the rationale was, and you know, I think that doing things in public really builds up the ability for other developers. Like, I've learned a lot just from observing other IRC conversations with other people, seeing how they discuss things and seeing how they were able to solve problems. And that really brings up the whole community, that sense of feeling involved. And really the idea that, you know, like we have a long ways to go. You know, we've been here for 20 years and we want to be here forever. And so retaining our history and that kind of institutional knowledge is incredibly important. And really the easiest way to do that is through transparency. And then about OpenStack. So the OpenStack cluster, I don't have any size details. It's called Wikimedia Cloud Services, and basically people can create VMs, and we have like a few other OpenStack things. I don't know the exact reason why OpenStack was selected. It was picked in like 2011, 2012. I do know that the main person who was hired for it was like a member of the OpenStack Foundation and contributing to OpenStack already. But I don't know why. I'm happy to like put you in touch with the people who do know the answer, or at least point you to the wiki pages that might contain the information if you want to find me afterwards. Yeah. Thank you.